Okay, I know you've all been waiting, just waiting to find out if there's a significant difference between the other groups. So like we said as we went through this example, we know there's got to be a difference between the therapy, this cognitive behavioral therapy group, and the placebo group. What we don't know is there a significant difference here between Prozac and therapy, and is there a significant difference here between Prozac and placebo? We notice that there's a 2-point differences here. We don't know if those 2-point differences are statistically significant. So what we're going to do is what's called post hoc tests. These are tests that we do after the fact. We only do these post hoc tests if our omnibus F ratio was statistically significant. This is our omnibus F ratio. Okay, we found that to be statistically significant. So now we can move on to these post hoc tests, and these are pairwise. We're making pairwise comparisons. And in some ways, you can think of these as almost kind of protected, what we call protected t-tests, if you will, almost, where we're looking at differences between the different conditions. And so what these do is they control for the experiment-wise alpha level, and there's a number of different post hoc tests that you can do, and there's whole graduate courses just based on post hoc tests, and we're not going to get into all the different types that you can use. Here we're just going to talk about Tukey's HSD. There's Tukey's HSD and there's Scheffé's that typically is used more often. And so this is controlling for the experiment-wise alpha level. What's the experiment-wise alpha level? So for this, as we make comparisons, if we're just looking at the overall test, we set our alpha at 0.05. But let's say if we're looking at, we decided to do 3 different t-tests, you might have said, why don't we just do on this data a t-test between Prozac and therapy, Prozac and placebo, and therapy and placebo. Well, if we set alpha at 0.05 for each one of those, and we did 3 different tests in that experiment, we add up those, the experiment-wise alpha would be 0.15. I'm completely simplifying this. It's not technically 0.15, but that's in essence what it is that takes place. Suddenly, this is unacceptable. So what we can do is look at the overall F ratio. If we find that to be statistically significant, then we can do these specific post hoc tests that control for this experiment-wise alpha level. So one of these is the Tukey's HSD, and so that's what we're going to do. We're going to do this by hand, and then I've got another video that will show you how to look at some SPSS output, statistical package that's used, and how to interpret post hoc tests through that. So here's a formula for doing the HSD by hand. It looks kind of complicated, and in some ways it kind of is and it kind of isn't. What we need is we need to look up Q in the back of the book. So we look up Q, and on page 593, we have the student range statistic for Q here, page 593. And so we're going to look up what's Q for our study. And so first we have to figure out K, what K is. And K is just the number of treatments that we have. So in our group, in our study, we had 3 treatments, right? Prozac, therapy, and placebo. So our K is 3. Then we have to figure out our degrees of freedom in the error term. What's this error term thing here? That's just another way of saying the within treatments is our error term. So the degrees of freedom in our error term was 15. Okay? So 3 and 15. And then we'll typically set our alpha at 0.05 again here for this experiment-wise, for these post hoc tests. And so our Q is 3.67. So Q equals 3.67. You notice how we got 3 and 15, 3.67 for our Q. Okay, and then we're taking this times the square root. So of the mean square within divided by the sample size that's found in each group. So our mean square within we found to be 2.93, right? That's our mean square within, 2.93. And then this is what's tricky, is that this n actually is the sample size for each group. And so one of the assumptions for using this Q by hand is that the sample size must be the same in all treatments. And that was the case in our study. Our sample size was 6 within each treatment. So we're going to divide this by 6 and not by 18. Okay, that's kind of the tricky thing for this. So again, there's the assumption that the sample size is the same within all treatments, which is a very specific assumption that's not going to work in all studies. So 2.93 divided by 6, 4.88, and we get the square root of that, 0.670 really with rounding, 0.70 times 3.67 2.56. Now what do we do with this number, this 2.56 number? Basically what we're doing with our 2.56 number is we make a comparison here with the mean differences that we have. Okay, so the mean difference between the Prozac group and the therapy group, that's a 2-point mean difference, right? We got 5 and 3. And so if that 2 points is smaller than 2.56, so we don't have enough evidence to say there's a significant difference between Prozac and therapy. And between Prozac and placebo, that's a 2-point difference as well. We're thinking in terms of absolute value of the score. That also is less than our 2.56 number that we have here. And so that's not statistically significant either. Our one that is between therapy and placebo, we already knew that would be statistically significant. That's a 4-point difference. That's larger than 2.56. So for that one, we say there's a significant difference between cognitive behavioral therapy and placebo. For this set of data, that's all we can say within this study. We can't say that therapy did significantly better than Prozac. We just don't have the evidence. It trends that way, but we don't have the evidence to be able to say that.